Hi, welcome to lesson 2 of week 1, Julia Programming for Nervous Beginners. Here we deconstruct lesson 1. So lesson 1 has just got very few lines of code, and you might think this is going to be a short lesson, but in fact it's going to be quite a long one. It's remarkable how much there is to talk about in those very few lines of code. So our aims are to deconstruct the code and to give details on what expressions are in Julia, and to convey to you the importance of writing valid code. And this, in the end, is how we start the process of very carefully learning the Julia language. You should be able at the end of this lesson to give examples of valid expressions, to explain the structure of a variable in terms of its name and its value, to explain exactly what a string value is in Julia, to explain in broad terms what a function is and how Julia recognizes a function, to explain how operators differ from other kinds of function, and to give examples of some Julia delimiters and of their use. Okay, so let's just revise. We had this code at the REPL in lesson 1, myString example 1 equals hello world, and println myString example, and we also have a file. We will refer to it in this lesson as myfile.jl. In fact, we called it myfirstfile.jl in the lesson 1. And here I've got a Julia REPL, and I'm just going to enter those code examples. MyString example 1 equals hello world. And you might as well do the same yourself. And println myString example 1. I just hit the tab key to complete myString example, by the way. That's why it happened so fast. We will not be referring to line 3 really in this thing. Let's look at line 1, which created a variable. So the way to read it, this line here, is that there's a left-hand side, a right-hand side, and an equal sign between them. The right-hand side is a string value. We'll talk about more later. The left-hand side is the name of a variable, and we'll talk about that more later. And then the equal sign binds it. So that we've already mentioned in lesson 1. And we've mentioned that it changes memory in your computer. So the equal sign is a special kind of function. It's called an operator, and its full name is an assignment operator. We say that line 1 created the variable because before line 1, this name was not part of the namespace. It was new, so that was why it was created. We could, in fact, assign it a new value. If we have this line, let me just use the up arrow, and I can put in something here. Arbitrary solids, whatever. It doesn't really matter what we put in there. It's just that it must be a string, and I can change it. I can change it to a numerical value if I like. I can just say 1.234, whatever. Anything that Julia will accept as a value can go on the right-hand side. The main point is that some value is on the right-hand side, and some name is on the left. That creates the actual, that's how a variable was created by that line. But now let's look at the actual components, the string value. So a string is a sequence of character, and what I mean by characters are the things like you type on the keyboard, but there are also more things that can be characters other than is just on a standard international keyboard. We'll get to that in a little while. In Julia, we indicate a string by enclosing it in a pair of double quotes. So if I type something on my keyboard and it comes up in the Julia REPL, and it is between a pair of double quotes, and that is supposed to be a string. Okay, but what do we mean by characters? So let me go to the REPL, and let's say I have A. It's not in any quotes, single quotes or double quotes, and I enclose it between single quotes. Then it tells me that this value is ASCII or Unicode of a different category, but all of these details are not important. Basically, the way to read it is to say that A is a character. So the A on the left is not a character, it's a name. The A on the right, because it's between single quotes, is a character. I can say that A equals B, for example. Then the name A is bound to the value B, and B is a character. B is a character value. I can, instead of binding the name A to the character B, I can bind it to the string. So this B is a string because it's between double quotes, and this B is a character because it's between single quotes. So if you use one keystroke of the international keyboard, like 1, 2, 3, and if you use the shift character, exclamation, @ hash, $, and many other characters that can be entered at the keyboard. So all of these one keystroke will enter a character, but there are many more characters that are valid in Julia. And they include characters from alphabets like Greek and Arabic and Sanskrit and many others. Even characters that are from non-alphabetic languages like Mandarin can be entered as valid characters in Julia, but we don't go into that in this course. It is beyond what we do. We stay simple with the international keyboard as far as possible. Okay, so the variable name. So variable names are more restricted than strings. Characters that Julia accepts in strings are almost any character at all, but they are not allowed in variable names. A variable name must start with a letter, and what counts as a letter is a big topic. Certainly, all of the letters from the alphabet, the Roman alphabet, they count as letters, and those are the ones we will use in this course. Julia accepts more letters than these, but on this course we will only use them. You start your variable name with a letter, and then you must continue it, and you can continue it using a letter or a digit. You can also use underscores or the exclamation mark, but we recommend against using underscores and the exclamation mark. Okay, so best practice in Julia is to use only lowercase letters and digits, and to use descriptive names such as we did with my string example 1. So that is the definition, the rules for a variable name. And now we can explain why line 1 is actually a valid Julia expression. So this line here is a valid expression in Julia. It's not merely an expression in Julia, it's a valid expression. Why? Because, firstly, it consists of symbols that Julia recognizes. If we try to use other symbols, of course it won't be valid. And then they are combined in a valid way into 3 groups. And then those 3 groups are combined in a way that Julia recognizes as a valid expression. So, which are the symbols that Julia recognizes? Very many, but we will only use the symbols visible on a standard international keyboard. Which are the valid groups? They are, of course, the name my string example 1, the equal sign, yeah, it is a group, although it has only one character in it, and this string hello world. So there's a valid variable name, a valid operator, and a valid string, and then they are combined according to the rules of the equals operator. That's the only way it can work. Left-hand side equals right-hand side. So it's only when all the parts of the expression are correctly recognized by Julia, and they're combined according to Julia's rules, that we have an expression which is valid Julia code. So the rules for making valid code are extremely strict. And we'll explain why in lesson 3. So finally, let's note that some parts of line 1 would by themselves be valid code, like the string at the end. We saw that you can just enter a string and it's valid code. But what that means is that a valid expression can actually be part of a larger valid expression. And that larger valid expression can itself be part of an even larger valid expression. So computer languages have this property that they can express bigger and bigger and bigger things. This will be important. So what happens if you enter invalid code in Julia? Well, you just get an error message. Let's look at a few examples. If you just have the equal sign, then you get an error message. Obviously, nothing can happen if you just have an equal sign. And even if you have an equal sign with a right-hand side, so this is just part of an assignment, just the right-hand side. There's nothing to assign it to, nothing to bind the value to, no variable name. And so we still get the same error message as before. However, if we just do the left-hand side, then when we try to execute that, Julia just hangs. It's looking for input. So, and it just sits there and it's waiting for input. So the error is that we haven't completed the line. Julia says, well, I can do something. If you just give me more, I can try and do something. And so if we put a string here, then it actually does come up. However, and this is something that might surprise you, if we take, let's just do the final example. If we want to assign the value to the variable name, this might seem reasonable to you as a human being. After all, this is a value, and here's a variable name. We're assigning a value to a variable name. What does it matter if it's left, right, or right, left? Well, Julia insists that the value is on the right and the variable name is on the left. And because it starts with a double quote, this expression on the left here, starting with a double quote, is not a valid variable name. It doesn't start with a letter. And so you get a message saying it's an invalid assignment location. Okay, so what happens then if we do this? Then, well, that's a valid that's valid code. So we should explain this. We would have thought that hello by itself is a valid variable name, but the comma surely should make trouble, but it doesn't. So to explain that, let me make it like this. The comma there is an indication that Julia should do multiple assignment. So it's not because hello comma is a valid variable name, which it isn't, because you can't use a comma in a variable name. But there's a special role for the comma. Because it follows a variable name on the left, the comma indicates that Julia should perform multiple assignments. So if we have two variable names on the left separated by a value, then what Julia echoes is the entire value of my string example. But if we ask for the value of hello, then it's just S, this S here. And so you can guess what the value of world is going to be. It's the T. So what's happening is that my string example is a whole lot of different actual characters. Yeah, okay, there's all these characters, S, T, R, I, N, G, comma, etc. All those characters are part of the string value of my string example one. And because hello world on the left is two variables, Julia is going to do multiple assignment to two elements on the right. And it can easily pull out the first two characters out of my string example one string value and assign them to hello world, and that's what it does. So the other thing to notice is that here we are assigning not to an explicit value as we did when we started out, but we start assigning these variables on the left to values represented by the variable on the right. So multiple assignment is a very nice way to write compact code which is easy to read, and if you do it well, it can really help to write code that people like to read, and that really helps with collaboration, and that includes collaboration with yourself sometime down the line, months or years later. when you're adapting your old code to some new purpose. I just want to say something about the difficulty of writing a valid expression in Julia. It can be very difficult in any computer language. If you try to write complicated long expressions, it can be difficult to ensure that they are valid. But that's beside the point. You can easily use very short, simple expressions, and you can easily make sure that they are valid, and most of the time that's what you'll do on this course. In fact, what we'll do is we'll gradually expand your ability to write valid expressions, so slowly as you go along, the expressions you form will become longer and more complicated. But the early ones will all be simple, as we've seen up to now. So let's go on to line 2, the println. So here is the content of line 2, println, myString example 1. And we call, this line calls println with the input myString example 1. So, for this to be valid code, println must be able to format the value. So what happens is, it gets the variable and it formats it, and then makes the output. This needs a bit of thinking about. The function called println myString example does several things. First thing, it sets up the function, so we don't worry about that. That's already done for us by built-in function. Then this code that is set up accepts the variable name, myString example. Then it fetches the value of the variable, and then it formats it. So there's many steps that are happening because of the simple function println. A function can involve very, very many steps, but we summarize them all just in the one name of the function itself. So then once it's done its formatting, it prints the formatted string to the screen. Because the string value of myString example 1 is so simple, there's very little formatting to do. And then it puts in an empty line, and then there's the next Julia prompt, again waiting for input. But now, Julia knows that println is the start of a function because of the character, the opening parenthesis, the left round bracket. And because there's a round bracket, it also knows there must be a closing round bracket. So there must be a pair of round brackets. And that's how Julia knows that it's a function, because there's no space. Immediately, there's an opening of a bracket after the name println. And then it also knows that what comes after the opening parenthesis is a list of variables. In this case, there's only one, but there can be more. I should say a list of values, really, when it's a function call. And after that comes the closing parenthesis. An interesting thing is that println by itself doesn't need any input. It just prints a blank line. So if there's no input, then what happens is that Julia prints on a line with a string with no characters, so it's an empty string, and it just prints a blank line. And then because it's println, it prints another blank line, and so you have two blank lines after the println. If you try and do the same with include, it says there is no method that works for include with no input, which is what we want, because we want include to actually run files that really exist. We can't run a non-existent file. That would be silly. Okay. Operators are, in a sense, a special kind of function. They mostly are mathematical symbols such as minus, plus, and so on. And the expressions they form have rules which often resemble the usual mathematical meanings quite closely. So we'll find out a lot more about these operators, but we won't talk about them more. The final thing to talk about is delimiters. So parentheses, because of here in the println with the open and closing bracket, they're very important in Julia, because in this case, for instance, they tell Julia where the input to the function starts and ends. And you've seen another pair of delimiters, which is the double quotes around strings, and they're also delimiters. They tell you Julia where the string starts and ends, and also the comma, where it was used to, in the multiple assignment example here, that comma there is a delimiter, sometimes also called a separator, but separators are basically delimiters as well. Okay, so this is what we have typed to make the valid code. Characters, you typed valid characters. So all the input was made with valid characters, and that's obviously essential. Once you're using valid characters, you can make them into values, as in the string variable we saw. You can make them into names that we saw, not only the names of the variables, but also the names of the two functions that we used. You can make them into operators. We didn't really see operators in action, but we will. And you can make them into delimiters. And that actually covers all of the valid code that happens on this course. So what you really need to learn are the values that Julia recognizes, how to make names in Julia, the operators that Julia recognizes, and how to use delimiters to make valid expressions combining operators, names, and values. That's actually all there is to valid code. Let's just review this. So Julia code has to consist of valid expressions. Otherwise, it's not going to run. That's absolutely essential. So I'll explain in lesson 3 why that is so very, very important, that we have the strict distinction between whether it's a valid expression or not a valid expression. So we used valid expressions concerning values, names, operators, and delimiters, and that's going to be true for the course as a whole. Names in Julia have to start with a letter. They have to continue with letters or digits or underscore or exclamation mark, and we strongly recommend that you only use lowercase letters and digits to make your variable and function names that you will write in this course. What is a variable? It is a name which is bound to a value, or if you like, it's a binding between a value and a name. It doesn't really matter how you think it, it's just that they are the two parts, the value, the name, and the fact that they're bound to each other. You can search for a value by searching for the name, but you can't actually search for a value by itself. Calling a function means you follow its name with parentheses, and the parentheses are surrounding values and or variable names, and of course these variable names will have values attached to them, so effectively they're also values. And that's what it means to call a function. You just type it in, the name of the function, you have a list of values, you put them inside the parentheses, and you execute that bit of code, and that's calling a function. And operators often do not need parentheses. They are often symbols like equals, plus, less than, and so on. And finally, the delimiters like double quotes, and parentheses, and also the single quotes around characters, they help to structure Julia code. They make it unambiguous, basically. And that's the end of lesson 2. So there'll be a little bit of an exercise, but then you should go on to lesson 3. Lesson 3 is the one, it's the one theory lesson in the whole course. It's a longish one. It's very important that you do look at the theory in lesson 3, because it will explain why we are so very careful to distinguish between valid code and invalid code, and what the thing is that decides whether code is valid or invalid.